As I mentioned earlier, a chassis consists of plates, frames, and joints. By modifying frames and joints, you'll be able to make finer adjustments to your chassis. Go into assembly mode, and I'll show you how it works. Here is a very simple robot that I've prepared for you. Isolate the chassis to enable editing. I hope you recall how to move a plate. Moving frames and joints is done the same way. Easy. Try moving the yellow frame. Cool. Joints can be merged together. Exciting stuff, isn't it? Now quit your robot and head over to the parking area to continue. That's an interesting design choice. Looking forward to seeing what you'll come up with next. So, moving stuff around sure is fun, but to make art, proper art, you need to step up your game. What you need to learn is how to extrude. That way you can create new plates, frames and joints from existing such. We will try this new feature on plates to begin with. Enter assembly mode and isolate the chassis. Go ahead and try to extrude the blue plate, or another one. Whichever one you like. I like blue. Great. Look at those shiny new plates that you have created. Using the extrude feature will allow you to build more complex and detailed chassis designs. Feel free to extrude a bit more, if you want to. When you feel done, print, park, proceed. And remember, you can always undo any action you're not happy with. I have to admit, I see great potential in you, and that makes me very happy. Don't touch me there. This is awkward. Leave me alone. Alright, thing to show you. The extrude feature is not only applicable on plates, but also on frames and joints. The method is the same, although the results you get will be different, depending on what kind of component you're extruding. For your final assignment, it's time for you to get your hands dirty. Figuratively speaking. Think outside the box and make your very own design. I have taught you how to fish. Now, go fish. Use the move and extrude features you've learned earlier and build something cool. The graduation ceremony will take place by the parking space. So, when you feel ready, head over there to present your piece of art. Do you like inspirational quotes? My favorite one is, "The world is but a canvas to the imagination." It's so deep. Make it work. That is so beautiful. You are a true artist. I don't know about you, but my right brain half needs a break. Thankfully, the next section is all about the left one. Welcome back. Now we will dive a bit deeper into what you can do with your robots. Let's look at some of the programming that you can do within your docking station. There are endless possibilities, but now, I will just guide you through the very basics. So, first off, as per usual, enter assembly mode, and then print the robot that I have built for you. Try to drive it. Doesn't work, does it? No. Let's go back to assembly mode and figure out why. Whenever you have a robot with a docking station on it, you can access its programming interface, the brain of your robot. Give me a minute and let me explain what you are looking at here. Here you can see your workspace and your list of nodes. The workspace is the grid where you place your programming nodes, and the list on the left contains categories of different kind of programming nodes that you can use. Right now all the nodes that this robot needs to drive are already placed in your workspace. But all the logic is not hooked up. You can see the wire connecting one of the input nodes to the steering node. But it looks like the other input node is not wired to the power of the motor. This is why you could not move forward or backwards. But don't worry, this is really easy to fix. On the right side of this node, there is a small dot. This is a chip pin that is used to attach wires. On the left side of the power node you have another chip pin. It's used for input to that node. This goes for any node in the programming. Input pins are on the left of a node and output pins on the right. To wire nodes together, you just drag a wire from the output pin up and voila! The input node will now send signals to your motor and give it power. Back out from programming and then print your bot to test it. Wow, looks like it's working. Cool. Drive to the parking spot again and I will give you another example. Alright. Bring up your assembly mode again, print, and try out this new... Have a look at the nodes here. Looks like we have inputs connected to the power of the motors, but no inputs for the steering. No wonder it was a bit difficult to drive. Since there are no more inputs placed in your working area, we will have to find them ourselves. Look at the list on the left. Open up the category called Inputs. In there you should be able to find a node called Input. This will make steering easy. Drag that node to an empty space in your... Now we just have to connect the two nodes, just as we did before. Drag it one... Now, select that node. Its properties should show on the left. There are some properties that we can change here to make it do what you want. One input box for positive input, which would be steer right, and one for negative input, steering left in this case. Interact with the Bravo. Now do the same thing. Sweet. Looks stellar. Back out of programming and then print this bot and see how it drives now. Smooth. Park this piece to continue when you are ready. Repetition time. Yay. Same deal as always. Enter. Oh yes. Programmer ace. Impressive. This was all I had for you right now. You should know it. Darn it. The sloppy person working on this bot seemed to have completely ignored to program this thing. Lucky for us that you know how to do this now. Let's see if you can figure this out. You will need to find the power and steering node for the motor. and then 2 input nodes to map the keys you want to use to drive this thing. And don't forget to connect them with some wires. Good luck. When you feel ready, you just back out to assembly mode again and then print it, and go for a spin.